Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 12 students and the topic of discussion is integrals. In this video, we will be giving an introduction to this topic. Now the question comes, what is integral? So let us first write a function, some example like f of x equal to 2x square plus 3x plus 6. We know its derivative, we have seen in our earlier videos, will be 4x plus 3 plus 0. Derivative of constant is 0. Now I want to put up a question. Suppose I am given a function like this. I want, and we know that this is derivative. Then I want to get the original function like this. Is it possible? That is the purpose of derivative. That what derivative will do or what integral will do. We are going to discuss integral. So integral f dash x will be f of x. So if we take the derivative function, put it under the integral sign, we get back the original function. So we can write like this: 4x plus 3 plus 0. We write here as a dx, means integration with respect to x. So always we write this dx. If it is with respect to y, then we will write dy. So this should give 2x square plus 3x plus constant. We always write one constant of integration. Whether that constant is 6 or 5, that we can determine through some initial condition. So now we are coming differentiation and integration difference we are seeing. So d by dx f of x is small f of x. Similarly, integral f of x dx, we get back the function f of x. So this symbol, this is the integral symbol. This is the integral symbol. F of x inside the integral is called the integrand. And it dx refers to with respect to what variable you are integrating. Here one example is given. If d by dx differentiation of sin x is cos x, then integral of cos x is sin x. So they are like reverse process. Differentiation and integral are reverse process. And often integral is called as the antiderivative also. So you should keep in mind. You may be asked in exam, find the antiderivative means find the integral. Some basic formulas we'll go through. This is one of the most important formula. Integral x power n is x power n plus 1 by n plus 1 for n not equal to 1, because if n is minus 1, denominator will become 0. So what happens for derivative of x power minus 1 or 1 power x, 1 by x? So we use this formula. If integral 1 over x is required, its integral is log x plus c. C is always added, a constant of integration. So what is derivative of some constant 1 dx is 1 can be written as x power 0. So its derivative using this formula will be x power 0 plus 1 by 0 plus 1, which is x itself. That's what we have written, x plus c is the constant of integration. Similarly, integral of e power x is e power x itself plus c. Integral a power x dx. Here a is a constant. Please remember, x, we are integrating with respect to x. So we know derivative of a power x is a power x log a. So similarly here its integral will be a power x will be equal to a power x by log a. So that's what we have written here. These are the basic integrals of trigonometric function. Integral sin x is minus cos x plus c. Integral cos x is sin x plus c. Integral sec square x dx is tan x plus c. Integral cosecant square x is minus cot x plus c. Integral sec x tan x is sec x plus c. Integral cot x cosecant x is minus cosecant x plus c. Now these are some of the properties of indefinite. You may be wondering why it is called indefinite. We'll see little later in the video. when no limits are put here, this integral is unbounded and we call it as indefinite. We'll see a word called as definite integral also shortly. So if we have a function f of x and it is being multiplied a constant k, then k can be taken as outside and the function becomes k into integral f of x. So we can write like this. So like 2 sin x can be written as 2 integral sin x dx. So constant can be taken out. Similarly, if we have two functions, then they can be taken out separately. For example, if you want integral of sin x plus cos 2x, then it can be written as dx sin x dx plus integral cos 2x dx. So we have separated the function and can find the integral separately. Similarly, we have the linear property also of the uh, integrals. If c1 and c2 are some constant and they are being multiplied on two functions f1 and f2, then it can be separated like this. Similarly, we have seen derivative of an integral is the function itself. We have seen derivative and integral are both anti to each other. That is why integral is called antiderivative. Similarly, if you take integral and derivative function, you get back the function itself. Now, what is constant of integration? It, it refers to an infinite family of curves that differ only by a vertical shift. Therefore, you must always add the constant of integration to your final answer. So in this problem, we need to integrate this function with respect to x. This is very important. Now, there are various ways of doing the integration. One of the method is substitution. By substitution, we make this function more simpler. So how do we make? We put x square equal to t. Then taking differentiation both sides, 2x dx equal to dt. So we write this 2x plus dx as dt. So integral 2x e power x square dx will be integral e power t dt. What is the integral of e power t is e power t itself with a constant of integration. Now putting back, we get this as e power x square plus c. Now in this we write this integral as cos square x cos x dx. Square x cos x dx. Now put sin x equal to t. So cos x equal to cos x dx equal to dt. So we replace this cos x dx by dt. So this will become integral 1 minus t square dt. Integral 1 is t. Integral of minus t square is minus t cube by 3. We substitute back because our final answer should be in terms of x. We substitute this t with sin x. So sin x minus sin cube x by 3 plus c. This is the value of this integral. Now we have some special functions like this tx by x square minus a square dx by a square minus x square, through which we can use directly these formulas 1 over 2a log x minus a by x plus a plus c and so on. We see for different functions like this. This you can remember. Now you may be wondering how you got. Let us take one example. This one, let us try to solve it. So we can write this as integral 1 by x minus a into x plus a dx. Correct? So we can write this as integral 1 over x minus a minus 1 over x plus a and this terms will give 2a in the numerator, so we have to divide 1 over 2a denominator and we get back this. Now integral of 1 over 2a can be common, so this 1 over x minus a integral is log x minus a. Similarly, this minus log x plus a, and this can be written as 1 over 2a log x minus a by x plus a. That's what we have written here, plus c, constant of integration. That's what we have written here. So I suggest students to solve this also similar to this. They are not difficult, they are easy, but you can use same principle like this. You may be wondering, suppose I am giving a factor like this. We have a distinct linear factors like this. These are distinct linear factors. Can we convert into a partial fraction like this? Yes, you can write a by x minus a by b by x minus b. It is important to note that we can convert to a partial fraction only when denominator power is more than the numerator. Here we see x square. So denominator should not be x square, or it should not have terms like x cube and so on. So its term should be below x square. So x is here. So this is okay. You cannot convert to a partial fraction like this, px square plus q divided by x square plus 3x square. This you cannot convert to like this. That will be wrong. So what we suggest, whenever you have a x term lower than the denominator term, you convert to partial fraction like this. You may be wondering, sometimes instead of x minus a, we may be given x minus a the whole square or x minus a the whole cube. Then how do we proceed? Then we can write denominator this term as a by x minus a plus b by x minus a the whole square plus c by x minus b. You may be wondering, if it is x minus a the whole cube, then we have to add another term plus d by x minus a the whole cube, and we have to evaluate a, b, c, d and compare with this coefficient p, q, r, and then determine a, b, c, d based on the coefficients of p, q, r, and then this can be integrated easily. We know that these are standard formulas. Suppose we are not given an equation which can be converted easily to partial fraction. We are given the quadratic factor which cannot be reduced. So it is irreducible. You cannot make it like x plus a the whole square or x minus a into x plus b, like that. You cannot make it. So how do we proceed? We write like this: x square plus a square, this is x minus b. In the numerator we write it as ax plus b, and this is c. Now here we are going to do function, what is integration by parts. In integration by parts, we mean if we are given two functions like this and we want to find their integration, then the formula goes like this: first function into integral of second function. It is this, like this: first function into integral of second function, then we put the integral, then differentiation of first function into integral of second function. So we are going to this. Let us try to find out the derivative or the integral with this. So this is the first function, this is the second function. So what is the derivative of cos x? Sorry, integral of cos x is sin x. So this we should remember. So we'll now use this formula: integral x cos x dx is equal to first function is x into integral of second function is sin x minus integral differentiation of first function, which is x, is 1, integral of second function. Integral of second function is, we already did, so we can write it sin x dx. So we got like this. This is x sin x. What is integral of sin x? Is minus cos x. So this will be plus cos x plus c. So this is our answer for this problem. Now you may be wondering, just for the sake of cross checking, if we differentiate this function, then we should get back this. Let us try to check this. So differentiation of this function, let us do it like first function into derivative of second, x cos x, plus sin x into derivative of x is 1, derivative of cos x is minus sin x, derivative constant is 0, so this will get cancelled. You will get x cos x as this. So sometimes if the problem is little simpler, you can just cross check it. Whatever you get the integral answer, you try to differentiate parallelly in a separate rough work and try to get back this function. That will be a good cross check. In the previous problem we studied x cos x and applied integration by parts. Now the question comes, we took x as the first function and cos x as the second function. Now the question comes, can we reverse it? Can we do like this, cos x, x dx? Yes, mathematically they are same, but it is more convenient if we take x as the first function and cos x as the second. For this case it may be trivial, you may take both, but for certain cases selecting a first function, which is the first function and which is second function, will make our life easy. So there is a rule called as the islet selection rule. What is that islet? If we are given an inverse trigonometric function along with anything, for example, if you are given sine inverse x and say x square, we want to find integral, then it is better to select sine inverse x as the first function than x square. It will make our life easier. So that is the reason why we have written I as inverse trigonometric function first, log first, then algebraic, then trigonometric and exponential. So that is why, see, in this function x cos x dx, x was algebraic function, so and cos x was trigonometric. So we selected algebraic function as the first function. In the formula we know integral f of x gx we have seen earlier. We have seen first function into integral of second function minus integral differentiation of first function into integral of second, we have seen. Now question is, which is first and which is second? That should be based on this rule. So if you are given two functions, check if algebraic function and exponential is given, you select algebraic first. If inverse trigonometric and exponential is given, you select inverse trigonometric as the first function. This is very important. We are talking of indefinite integral which were unbounded. Now consider a function like this. Let us take one function. This is say y equal to f of x. This is x. This is some function like that. We have drawn like this. And let us say it is from a to b. This is a to b. Now the definite integral is given by this f of x dx a to b. So what is a to b? It is telling the integral is the area under the curve f of x. This is f of x curve. So this is area under this curve is given by integral from a to b f of x dx. So the integration basically means summing up. So summing up the area from here to here is given by a to b integral f of x dx. What is this a and b are called? This is called lower limit. This is called upper limit. So one of the important application of integration is finding the area under the curve. Let us take one simple example here. Integral x square dx from limit 0 to 2. So integral of x square is x cube by 3. So from limit 0 to 2, now we first substitute 2 into x. So 2 cube by 3 will be 8 by 3 minus 0 by 3, which is 8 by 3. So this is the way definite integrals are worked out. This is one very important property. If we change the limit of the integral from a to b to a, then we need to change the sign. We need to put additional negativity here. We need to change the sign of integral. If we change the limit from lower to upper, we need to change the sign. If the two limits are same, then the integral is 0. The value is 0. It makes sense. Suppose this is some function and you want to find area between a and a itself, then there is no area. This area is 0. Indirectly it means that is why it is put here. If you put additional limit here, instead of a to b you want to put a to c and c to b, then it can be function can be written like this. Also makes sense. You take a function here, instead of finding from a to b, you have intermediate c. So if you take from a to c this area, then from c to a this area, so that will correspond to the whole area on this. So that is why we can write integral a to b f of x dx is a to c plus c to a.